So welcome my dear students. Already we discussed about atomic radii, right? So the distance from the center of the nucleus to outermost shell outermost electron where the electron is present is called atomic radius, right? So it is classified into three types like covalent radius, van der Waals radius and metallic radius. So van der Waals radius is a larger radius than metallic radius. Metallic radius is also larger than covalent, means covalent radius is a very small radius. Okay, like that we discussed, and trends in the periodic table also we discussed that atomic radius left to right in the periodic table decreases, we said, because of the attractive forces increasing due to increasing the nucleus number of in the nucleus number of protons increasing. So all protons pull the electrons in the inside the nucleus. That's why size decreases, we said, in the periods. And in the groups, shells increasing, so atom becomes larger and larger if going from top to bottom, we discussed already, right? So this is because only increasing shell in the top to bottom, left to right shells not increase, only number of electrons in the same shell number of electrons increases. That's why in the same shell number of electrons increasing and number of protons also increasing in the nucleus, so all the electrons are pulled towards the nucleus, so atom size decreases, we discussed it, right? So in this class we are going to discuss a very important class. So it is the duster, duster. So today in this class we are going to discuss about ionic radius. So in this ionic radius, I will explain some important points here. You please note down all of them. So ionic radius, very important ionic radius. So in this radius, I will explain you very important points. Okay. So you please try to note the important points. What is ionic radius? In an ion, not atom, no, ions no. In an ion, the distance from center of nucleus to outermost shell, outermost electron is called ionic radius. Here ions are classified into two types, right? Two types of ions are there, we know that. So cations and anions. So see, this ionic radius varies in the cations and anions. In the anions, atomic radius is different, and in the cations, atomic radius is different. So let us discuss in the cations first. What are cations? Cations are the ions formed by the loss of electrons. For example, let us take sodium. Sodium having how many electrons? 11 electrons. What will be the electronic configuration? 1s2, 2s2 and 2p6 and 3s1. It means the nucleus of sodium, let us consider this is, and the first shell of the sodium, maybe this is, let us assume, and this will be the second shell, and this will be the third shell. Okay. So sodium generally in general it is metal, no? So loss electron and it converts into sodium metal Na plus. So whenever the sodium metal formed, so only the number of electrons present is only 10. Whenever the sodium forms ion, so it lost one electron, so the total number of electrons becomes 10 only, right? So the electronic configuration becomes 1s2, 2s2, 2p6 because the 3s electron, last electron is removed. Last electron is removed. So the last electron in the sodium atom is present in the last shell. So these two electrons, this is third shell, that's why third shell, no? So that's why that electron is present in the third shell. Okay? 3s electron is present in the third shell. This is second shell, right? So second shell having how many electrons? 2 plus 6. Total 8 electrons are present. 8 electrons are present in the inner shell. So in the first shell, how many electrons we have? Only 2 electrons. Only 2 electrons. Are you able to see the diagram clearly? Okay, right. Next. So these 2 electrons are inner electrons or core electrons we can say, and these are penultimate electrons or penultimate electrons. These are called valence electrons. These are called valence electrons or ultimate electrons or outermost electron. So whenever this electron removed, in the case of sodium, the radius will be measured from center of the nucleus to the last electron where it is present. So this may be R1. Let us assume R1. So after losing that electron, so this electron loss, so electron loss means no shell or no orbit. So we have to consider only up to where the electrons are present according to definition. According to definition, we have to consider up to only where the electrons are present. Previously electron is present here, but after losing electron, so that electron is not there. So similar, that's why that shell will be not there. That should not consider. Now only electrons are present up to only second shell. Now tell me, R2 second radius is less than R1 or greater than R1? Definitely less than R1. It means when compared to the parent atom, this is parent atom or parent element, that ion, if positively charged, very important, if it is a positively charged ion, ionic radius is less than parent atom or generally element than element or neutral atom Okay, understand? So positively charged atoms are having less, so Na plus having less ionic radius than sodium. This one having less radius than sodium metal. Less radius than sodium metal. Okay? Understand now? Next, let us talk about anions. Anions radius, what happened? Let us discuss. So, here one more important point in the cations we forgot to discuss. So, due to positive charge, one more proton free now. So due to that free proton, all the electrons, attractive forces on all the electrons increases, because this proton shows as simultaneous force or same force or similar force on all the electrons, so that all the electrons are pulled towards the nucleus. That's why the positive charge increases. As we discussed in the atomic radius, positive charge increases, the size decreases. That is also one of the reason why sodium atoms, neutral atoms, having more size than ions, positively charged ions. Understand? So any doubts in this? Next. So here anions, let us talk. What are the anions? First of all, anions are the negatively charged ions. They are negatively charged ions. These are negatively charged ions. Like, let us assume an example. Okay, so let us take fluoride. Okay, so fluorine generally atomic number 9, electronic configuration 1s2, 2s2, 2p5. So this is the, for example, fluorine atom. 2 electrons are present here in the first shell, and total 7 electrons are present in the outermost shell, in the fluorine atom, not in the ion I am telling. First of all, take fluorine neutral atom. This is the actual situation in the fluorine neutral atom. Okay, fluorine neutral atom, this is the actual situation. So now you take fluoride ion. Fluoride ion means one more electron is added to fluorine. Electrons numbers become, so 10 electrons, one electron is added to the fluorine neutral atom, so that it will get a negatively charged atom. So here, so if the one more electron is added, then total number of electrons here in the outermost shell becomes 8 electrons. Okay, 8 electrons. Okay, 8 electrons are present in the outermost shell, but how many protons, positively charged protons are present are there in the nucleus? Only 9, because number of protons and number of electrons in the atom are same. But here in an ion, so what happened? One more electron added, but proton not added. Electron added, but not proton. So what happened? Now these 9 protons only has to attract 10 electrons. So overall charge on the 10 electrons by these 9 protons. So I will explain you by taking one example. Suppose you have 9 apples and you are all 9 members. So each person will get 1 apple, exactly, right? So 9 members, 9 apples. You will get 9 exact apples. So each person will get exactly 1 apple, right? So if suppose you are 10 members, only 9 apples are there, how can we share? So definitely every person or each person or single person will get less than 1 apple or not. It means the percentage of the apple, what happened? Reduced. Similarly, if the electrons are more than the protons, the overall charge, what happened? Reduced. The overall charge on the electron, so attractive force on the electron decrease. Because in the previous case, that 9 protons are exactly attracting by 9 electrons. So charge will be equal. That's why electrons are exactly attracting. Now one more electron added. So to attract that electron, some of the charge, nuclear charge, so no extra charge is there. So that's why some of the charge is reduced on all the electrons. So that charge will be given to, or that force of attraction will be used to attract the 10th electron. That's why the overall charge or overall attractions in the fluoride atom or negatively charged atom decreases. Negatively charged atom decreases. Understanding? Okay. So negative charge increases. So positive charge not increasing. So overallly the size of the atom. So due to less attractions, the electrons are somewhat moved so far from the nucleus. That's why the atom, so nucleus in the initial case, for example, it is the distance. In the after gaining electron, the size of the fluoride atom is like this. What happened? Size increased due to less nuclear force on the electrons. So less nuclear force is there means they will move apart, away from the nucleus. Electrons moves away from the nucleus. If the attractive forces are more, then only nucleus attracts well, then only electrons comes near to the nucleus. Okay, I hope you are understanding. If you are having any doubts, you can just give me a hint. I will explain once again. Okay, so because it is a very important topic, ionic radius. Okay, that's why I am explaining in this slow manner. Here nucleus if attracts strongly, then atomic size decreases. If the nucleus not able to attract the electrons, then atomic size increases or ionic radius increases. Okay, suppose parents in your home, if parents are taking very well care on you, then you are very close with your parents, right? If your parents are not taking much care, then what happened? You are also just whatever the needs are there, you will ask to your parents. Otherwise, you are not going to disturb your parents. Okay, so like that. So whenever the attractive forces are more, then the nucleus attracts well. It means I am not telling that parents all are bad. Okay, don't take that meaning from my words. Okay, so when the electrons are attracted by the nucleus strongly, so nucleus atomic ionic radius decreases. So when the nucleus is not able to attract the electrons, it means more electrons are present than the protons, so the size increases. So in the negatively charged ions, ionic radius is greater than neutral atom. Okay, neutral atom. Understand? If you understand this one, then we will give you a finishing touch to our topic. Are you able to understand? Okay, right. Next, now I will explain one more point. So, if the positive charge is going on increasing, going on, then atomic size going on decreasing. Suppose if the positive charge is 1, if the neutral atom, suppose this much size, let us assume. Okay, so 1 electron is removed, size decreased. So 2 electrons removed, so positive charge increased, no? Positive charge will be the same. So number of electrons less. So what happened here? The size decreases. For example, I will tell you one very best example. Okay, to you. Suppose 9 members are there. 9 apples are there. This is called a neutral atom. Okay. Apples are here considered as the electrons. Apples are considered as the persons are considered as the electrons. 9 members are there, 9 apples. Apples are protons, P. Okay, right? Now, 9 members are there, 9 apples are there. Exactly, each person get 1 apple, right? Or each apple will be given to 1 person. So exact changes, exact attractions. Now, persons means electrons increased. Electrons increased. So what happened? Number of apples what actually has to share will be less. So in the 9 members are there, 9 apples are there. Each person will get 1 apple. Now when 10 members are there, each person will get less than 1 apple. So only 8 members are there, or only 4 members are there. What? Each person exactly gets nearly 2 and half apples, or nearly 2 and more apples. It means here attractions increased. 2 apples means more attractions. 2 protons attracting 1 electron, meaning 2 protons attracting 1 electron. So force will be, attractive force will be very high. So only half proton means less amount of proton charge is attracting 1 electron is weak force of attraction. So that happens in the case of addition of electron. When an electron added, a nuclear force is not sufficient to attract that electron. So overall the size of that electron enters in the outermost shell. So the force is not sufficient. So the radius, what happened? Increased as compared to this radius. So this time, so R1 is greater than, R1 is less than R2. In this case, both are same. No. R1 is, both are same. No, here it is R1 is greater than R2. Here R1 is less than R2. First radius is less than after the formation of ion. Here the first radius is greater than after the formation of positively charged ion. Okay, so sorry, I did a small mistake here on the symbols, mathematics symbols, because I am weak in mathematics. Okay, so R1 is less than R2. It means, so in the negative charge, in the negatively charged atom, in the negatively charged ions, size is more than the neutral atom. Here one more point I would like to explain. Here positive charge going on increases. What happened? Size decrease, or radius, ionic radius decreases. I will try to explain with one example. Aluminium plus 1, aluminium plus 2, aluminium plus 3. He will ask you a question like this in the competitive exams. Which are the following species, simply because here ions are there and a neutral atom is there. So we should not say only ions. Species means comes all. Okay, ions and atoms all will comes under the species. Okay, so which of the following species have larger ionic radius, or large radius, simply large radius? Okay, or if he will give only these 3, which of the following will have larger atomic or ionic radius? Which of these 3 having large ionic radius? So I told you just now, positive charge increasing, ionic radius decreases. Positive charge increasing, ionic radius decreases. So left to right here, positive charge increasing, so ionic radius, what happened? Ionic radius. What happened? What happened, man? Decreases. So aluminum plus 1 will have more ionic radius compared to plus 2. Plus 2 will have more compared to plus 3. Plus 4 is there means that is only the least. So options will be given give like this. So option A Al plus, option B Al plus 2, option C Al plus 3, option D all have same ionic radius. Immediately what you people choose? So only aluminum no, all aluminiums no. So all are having same. So that's why D is the correct answer. No, not at all. Remember, D is in not at all answer, correct answer. C is the correct answer because aluminum plus 3 will have the least size. Okay. Next, here. So negative charge increasing going on. Suppose for example, let us take oxygen O minus and O2 minus. So among these two, which ion having large size means size increases, negative charge increases, opposite to positive charge atom. So here positive charge increases, size decreases, or ionic radius decreases. Here negative charge increases, ionic radius increases. Ionic radius increases. That's the main important point you have to remember. Now, one very important topic I am going to explain, that is nothing but isoelectronic species. Very important number. So in every competitive exam, definitely you will get at least one example like this, what I am going to tell you. Where every competitive exam. So isoelectronic species. Isoelectronic species. Very important. Isoelectronic species. Definition not they will ask you. But based on definition, some examples are there that are very important. Okay. So what are first isoelectrons? Iso means same. Electronics means electrons present in species. So atoms or ions having same number of electrons. Atoms or ions having same number of electrons. Same number of electrons are there, then that is called, we can say, isoelectronic species. I hope you understand. Okay, I will give you one example also. So neon atomic number how much, ma'am? 10, right? So how many electrons are present? 10, right? So sodium actually 11. Sodium plus Na plus lost one electron. So after losing one electron, Na plus will have how many electrons? 10. So these two species are called isoelectronic species. These two species are called isoelectronic species. Next, fluorine actually 9 electrons are there, but F minus after gaining one electron, it have 10 electrons again. So these three species are called isoelectronic species. And if fluorine gain 1 electron, 10, oxygen 8 actually gains 2 electrons, 8 plus 2, 10. Nitrogen 7 gains 3 electrons. 7 plus 3 gains 3 electrons. Magnesium 12 atomic number means 12 electrons will be present. Lost 2 electrons. So 12 minus 2, 10 electrons. Right? Understand? Easy no? Isoelectronic species means atoms or ions having same number of electrons. Easy no? Bit also very easy from this topic. Okay, I will tell you what type of bit we will get. So simply he will give you this type of series. Okay, isoelectronic species he will give you. Okay, all are having same number of electrons. Now he will ask you which of these elements or ions, which of these species are having highest atomic or ionic radius? Highest atomic or ionic radius? Definitely which one? As we discussed just now, so which is having more negative charge, that is only the highest. So more negative charge is present for the nitrogen, so that's why nitrogen having highest ionic radius. Smallest ionic radius, positive charge will be more than that having smallest. So here also positive charge, here also positive charge. Which is more? This one. So this is having least ionic radius. Suppose instead of this, if one more electron, ion is there like this, Al plus 3, definitely the answer will be for the lowest ionic radius having species means having which having highest charge of positive, then that will have lowest ionic radius. Okay, understand? This is about ionic isoelectronic species and ionic radius. So I hope you understand. Please, once again I am telling, from this topic, isoelectronic topic onwards in this video, once again you see, you practice the bits from this isoelectronic species, from the net you download or from any source you take these bits. Definitely from this topic you will get at least one question from the in the JEE and NEET examinations now. Very important topic in the ionic radius. That's why I explained this class very slowly. Okay, so you please try to understand this topic and see twice, thrice this video. Okay, and try to practice the bits from this topic. Okay, so anyhow, I hope you all understand. If you have any doubts, you please come in the Zoom interaction and interact with me so that I can clarify your doubts. Okay, thank you.